Welcome back. We now transition into our lunch session talk for those who are still working on their food. Our guest today is visiting from Japan. Please extend a warm Texas welcome to Takuya Fujii-san. Takuya Fujii-san will discuss Texas-Japan quantum manufacturing collaboration, highlighting their specialization in magnetic field measurement and magnetic field technologies essential for quantum technologies. This session will highlight how cross-border collaboration strengthens supply chains, accelerates commercialization, and builds trust quantum manufacturing pathways between Texas and Japan. Again, welcome.
Thank you so much. Okay, thank you introduce me to about my company and my name, and then also first of all, thank you Rashimi-san for inviting me to the third annual Texas Quantum Economy Conference. I am so honored to join a part of this event, a conference, and then also I'd like to thank you, City of Richardson for Economic Development Director Chris and its manager of Brandonson. Thank you so much. Okay, so I'm Takuya Fujii, and nickname is Jimmy, so it's easy to remember. So my United States partner give me my name, the Jimmy, so just call me and Jimmy. Okay. So Ohtama has a very close ties to Texas, and I am here to install our product's magnetic shield chamber to the customer located in Allen. I think it takes from the 20 minutes by car, right? And then also last year, we installed the same chamber in Austin. So Ohtama very close to the Texas business. And then our technology is essential to supporting cutting edge technology, and we are extremely proud to be able to enrich people's lives and contribute technological achievement through it. And so let's explain about Ohtama and its history, and then what we can do, and also the relationship with quantum computing. So Ohtama, founded over 60 years ago, is a company that specializes in magnetic field control, and one of the few companies in the world that specialize in this field. So previously, we manufactured magnetic shielding parts for CRT television and magnetic heads for hard disk drive, but this has declined over the time. And now we focus on advanced technology field, such as cutting edge chips for AI and data center, and semiconductor manufacturing tools, and so on. And so semiconductor industry market shifts quickly. 20 years ago, the chips manufactured in Japan, but now semiconductor production shifts overseas. So Ohtama has also seen an increase its business with overseas companies. So, and then Ohtama plans to open market right now, so I cannot say the detail of the sales figure, sorry. So, what's Ohtama's main business is producing the magnetic mu delta metal. So what is the mu delta metal? So soft magnetic material is called mu metal or permalloy, but we call mu delta metal, which is made by Ohtama. So Ohtama is manufacturer that processing and heat treatments soft magnetic material to create magnetic field shielding parts that that assembled into customers' products to protect them from the magnetic field noise or collect magnetic field like core and yoke. So the material is all the same, but the manufacturing process is a bit different from each supplier. Ohtama can provide you sheets of mu-delta metal, which is annealed or customized processing parts itself. And we have a test material for mu-delta metal, so you can try it. So I have a short movie, and it's easy to understand how to magnetic shield. So this is the demo cathode tube. So many general people are unaware that this technology is necessary in semiconductor manufacturing process and is used in quantum computers. Also, I didn't know that before I worked at Ohtama. So now the magnet rotates right now by rotating magnetic and influenced by the E-beam. So now covering the normal stainless. So the E-beam is still rotating. That means still influenced by the magnetic field fluctuation or movement. The next, and we cover the mu-delta metal. So cover tube. And watch the beam, it's just straight up. So you can see that electron beam extends straight. So this is what we do think. So at Ohtama, we have the integrated production process in-house. The entire process for mu-delta metal from fabrication to heat treatment is handled in-house and equipped with various furnaces from small to large scale. We respond flexibly to needs ranging from prototyping to mass production. And then this is our new fab. We started to operate new fab in 2023. We have expanded our production facility to meet the needs of even more customers. So we just only buy from the raw material from Europe, and then tons of stock in-house and processing, annealing, and inspection. So we have the integrated in-house production system. This is a very few in this field kind of have the system. So, so now we talking about quantum computing and Ohtama. So this is the first time business to quantum computing industry collaborate with QIQV at Osaka University. Ohtama's magnetic shield performs well even in extremely low temperatures. I mean the cryogenic. So the quantum state of superconducting qubits changes when exposed to external magnetic field. There are many external magnetic fields around qubits, including the Earth's magnetic field, magnetic fields from other experimental equipment, and magnetic field fluctuation caused by the movement of magnetic materials such as an elevator. So magnetic shielding to block the effect of these external magnetic fields is essential for research. And in addition, because of quantum computers use heat conduction to lower their temperature, it can also be combined with copper, which has high thermal conductivity. You can see the copper, the plating right there. So magnetic shields for quantum computers are used in a cryogenic environment of minus 273 Celsius, and Ohtama is conducting research to improve performance in cryogenic environments. So even if our material is a normal mu metal, so we have to research for being chosen for our material. So first reason, in generally, magnetic shield parts for quantum computing are used in cryogenic environment, and surely those must be developed for cryogenic. So the QIQB initially used a different supplier, but they choose the mu delta metal. So because we have much experiment under the different condition in annealing temperature and time, and this allow achieve the potential mu metal in cryogenic. So we found that there is no significant differences 30 through 40 ampere per meter. This is the geomagnetic field like that. So our magnetic shield perform on par with cryogenic grade materials in Earth level magnetic fields. So we achieved two significant cost reduction, cutting expense to about 1/3 by opting for our solution over conventional cryogenic materials. So this is not the model of the quantum computing parts, just you saw the cylinder type. I just pick up the sample pick. And then, while the user initially utilized two-layer shielding, so our simulation analysis demonstrated that the single layer was more than adequate. So we proposed the customer to achieve the required performance at less than 50% of original cost. So Ohtama always proposed the best solution, eliminate waste and cost reduction, and make proposals that satisfy our customers. And we offer you any shape of the parts for simulation. Okay, so now telling about more in detail about Ohtama. So I tell you what Ohtama can do. So Ohtama is not just only manufacturer, but also magnetic field consultant. So we can offer you total service for magnetic field controlling, like magnetic field measurement and simulation, and also offer you a active magnetic field canceling system. So we know and propose the best way to control magnetic field for customer requests. Okay, and then this is our business market. So of course, semiconductor, and then electron microscope, medical, quantum computing, aerospace, and accelerator. So our sales of 70% comes from for semiconductor right now. So this is the active counter. The number of electron microscope and direct wafer writer is increasing rapidly. They are being used to meet the growing demand for research and non-state-of-the-art semiconductor. For example, chips for memory and data center. If it is unnecessary to shield more sensitive magnetic field, you can use the active magnetic field canceling system. It is more simple to install it with their devices required to shield the magnetic field, like electron microscope. So this is our Ohtama's customized the system, which go down the 0 hertz through the 1,000 hertz. Okay. And then this is also the JAXA managing test facility and conduct research and the development of test technology for the development of spacecraft. So we can offer the aerospace for research. So magnetic shielding box and the cylinder type is very beneficial for them. So this is the standard box, and then we have 3 types of standard shielding box, and 1 layer, and a double layer, and a triple layer. And of course, we are good at the customized boxes and the cylinders. So just let me know what kind of the size and then layer, and then also we can simulate the best way your request to meet your spec. And then also one collaboration with Michigan University. This is for Philippe. Those are also used by cryogenic environment. This experience led to its current adoption in quantum computers. Okay, so now last one is for semiconductor products. So each 13 feet size of magnetic shield chamber with air conditioning system. This is more high sensitive magnetic field attenuation. Cutting edge semiconductor production must be needed by our chamber. So it is necessary to manufacture a photon mask, which are one of the process in semiconductor manufacturing. And then also we can do the simulate the kind of the huge chamber thing. And then the top of the left corner of the room is there's no door. So it's critical for the huge hole coming inside the magnetic field, but we can do the simulate for how much inside the magnetic field left. So we can do the open space, and then the customer, always open the door, so just comes through the research and development. So lastly, one more video. I show you the magnetic shield chamber, one with a huge end, and you can see the process of how it builds. So we decorated the finishing panel after the mu metal attached. So shielding metal is not reflect to the magnetic field. They are passed through the inside soft magnetic material. So this is how to shield it. So our cells getting larger and larger every year because of the now the semiconductor industry getting larger and larger. This chamber is not for semiconductor one, but so we cannot take a video inside a semiconductor fab. So Okay, so in the Texas, we have a track record of providing magnetically shielded room and shielding components for the semiconductor industry. However, we are just getting started and we will try to break into other industry. Of course, the United States market is expected to consume much material in R&D larger than Japan. So there is achieved investment in the development of not only semiconductor, but also quantum computers, aerospace. So there is urgent need to advance high technology in the US market. So I'll say again, the Ohtama is happy to be able to enrich people's lives and contribute technological advancements through it in the US, of course, in Texas. So if you have any interest of Ohtama or if you have already some problem about magnetic field noise, just let me know, and we think to solve the solution together. So thank you so much for your attention.